The modern commercial or office building consists of many sophisticated systems. These systems include foundation and support structures, electrical and lighting, and plumbing and fixtures. Another major part of any building that is often taken for granted by its inhabitants is the HVAC system. HVAC stands for heating, ventilation, and air conditioning. In this unit, we will identify the purpose and goals of the HVAC system, describe basic HVAC parts, and describe how these parts work together. Air quality is an essential consideration in maintaining the productivity, comfort, and health of the occupants and should not be trivialized. If air quality and temperature are not maintained, occupant comfort in the workplace can suffer, directly affecting productivity and morale. The goals of an HVAC system. When examining the design of an HVAC system, we must remember the various roles that the HVAC system plays. We all know that when we're cold, we turn the thermostat up for more heat, and when we're hot, we turn the thermostat down. So the HVAC system keeps us comfortable by adjusting the room's temperature. But equally important, the HVAC system must keep occupants comfortable by supplying fresh air to a room. If we introduce a significant proportion of fresh exterior air and alleviate carbon dioxide buildup, occupants experience better health and performance gains. Studies have shown a direct link between CO2 levels and short-term sick leave in office workforces. However, our concerns regarding the HVAC system and occupant health do not end here. In heavily air-conditioned, energy-efficient environments, recirculated conditioned air can carry contaminants which contribute to respiratory illness. It is the HVAC system's job to remove contaminants and dust from the air using filters at various stages. As important as this consideration is in an average office or commercial building, this feature is critical in facilities that contain clean rooms, medical facilities, or hazardous materials. Finally, with the spiraling cost of fuel, HVAC systems must also be efficient and economical. Energy-efficient HVAC systems might incorporate variable air volume designs, components designed for operation at low pressures, digital control systems, mechanisms for reclaiming heating or cooling benefits from recirculated air, and high-efficiency ECM fan motors. Many price products are designed specifically with energy efficiency in mind. By understanding the importance of occupant comfort, we realize the significance of the HVAC system in a building design. It's responsible for controlling the temperature in the environment, providing fresh air to the occupants, filtering out dust and contaminants, while operating in an energy-efficient and unobtrusive manner. The following section covers the different parts that make up a basic HVAC system. Once we understand the range of components involved, we can better understand the reasons for choosing system components from Price's extensive product line. The parts of an HVAC system. The HVAC system installed in a commercial or office space differs greatly from the heating and cooling system that you might be familiar with in your house. In your home, your heating system is set up to deliver warm air during the winter and cool air in the summer. It does this using a furnace or an air conditioner and a common set of ductwork. When your thermostat detects that your home is too cold, it sends signals to the furnace, which then delivers warm air simultaneously to all parts of your house. Note that it is typical to have only one thermostat, and it does not account for temperature variation in any other rooms. Likewise, in the summer, your thermostat will detect when your home has become uncomfortably warm, and it will signal your central air conditioning system to deliver cool air simultaneously to all parts of your house. Again, note that your thermostat is measuring the temperature in only one room. The conditions in an office or commercial space are quite different. Higher concentrations of people and equipment will generate more heat, making air conditioning or recirculation of air more important than providing heat. Although the air handling equipment is centralized, different rooms and regions in the building will have different needs for heating and cooling. These needs are called loads because they place a load or demand on the HVAC system. These loads can come from equipment, people, weather, and many other factors. In the simplest case, we address this by providing a constant supply of cool air, which is then managed by the HVAC distribution system. The chiller or air conditioner utilizes heat exchangers and circulated fluid or gas to cool the air that is passed through it. The air handler is a fan or a blower that moves air throughout the building's ductwork. Axial or centrifugal fan types may be found in the air handler. Air filters. Depending on the requirements of the occupants and the activities in the building, various grades of air filters are used in the system. General purpose air filters will be included in the air handler itself, while more sophisticated filters, such as HEPA filters, may be used in the downstream ductwork. Ductwork. Round, square, and rectangular ductwork provides a pass for the conditioned air from the air handling unit to the environment. A damper consists of one or more blades which can be used to control the amount of airflow through a duct. Manual dampers are used to ensure that different parts of the building receive proportional ventilation based on area and demand. Automated dampers may be installed at firewalls which close in the case of a fire. A terminal unit is a device that uses an automated damper to control the amount of air which is delivered to a room or region. The damper is typically controlled by an electric, pneumatic, or digital actuator, which in turn is regulated by a thermostat. A set of adjacent rooms or regions in a building which have identical heating and air conditioning needs are called a zone. It is typical to assign at least one terminal unit and corresponding thermostat to each zone. Price manufactures many different varieties of terminal units to suit all types of building needs. We discuss terminal units in greater detail in the forthcoming terminal units section. Heating coils may be installed after a terminal unit to provide heat on a zone-by-zone basis. As mentioned previously, buildings with a high number of occupants may not require extensive heating even during the coldest months of the year. Heating coils offer an efficient way of providing heat for those few areas that require it and are controlled by the same thermostat system as the terminal unit. Various types of linings are available to dampen noise within a duct. A short length of line ductwork, called an attenuator, is often installed following the terminal unit to dampen discharge noise. Ultimately, the test of an HVAC system lies in its ability to deliver conditioned air to the occupant. Air from the ductwork enters the occupied space through grills, registers, or diffusers, often called GRDs. The term grill is commonly applied to any air outlet or intake that consists of a square or rectangular face and neck and whose facial appearance is made up of louvers which may be used to deflect the air. A register is a grill that has one or more adjustable blades or dampers that control the amount of air that flows through. A diffuser is an air outlet which incorporates structures such as vanes, louvers, perforations, and other features for distributing and directing air. The diffuser's job is to direct the airflow throughout the occupied space in the most efficient manner possible. More information on desirable air patterns is provided in the space air diffusion section. We will discuss diffusers in more detail in air outlet selection. Once air enters a space, where does it go? Air circulates through the return inlets and returns to the air handling unit. Unlike an air outlet, a return requires no sophisticated vanes. However, the relative location of the air inlets and outlets can be critical to the efficiency of the system. Upon returning to the air handler, a certain portion of the return air is exhausted and replaced with fresh exterior air. In an average office building or commercial space, approximately 10 to 20%. For an interactive look at an HVAC system in action, experiment with the activity provided here. Use the thermostats shown to raise or lower the temperature in the room. Watch how the different parts of the system respond as you call for heating or cooling.
It's hot enough to cook an egg on my desktop. Somebody ought to open a window or something. a break. We're roasting in here. Is it just me, or is it hot in here?
The preceding information offers a very basic overview of the components that make up an HVAC system. Throughout the remainder of the training module, we will examine many of these components in greater detail. We hope that you've enjoyed this introduction to the basics of HVAC. Please refer to the price catalog for more in-depth information and descriptions of specific HVAC products shown in this unit. Contact your local price representative or visit our website at www.price-hvac.com for more information.